Okay, today we are going to talk about the calculations of solar charge controllers or regulators. You remember we started the chapter of charge controllers. Now we talked about the PWM and MPPT. Those are the two types of charge controllers. Now today we want to see how we calculate and how we know the panel which regulator we shall need. Okay, we want to see if you are designing your solar system, how can you know which regulator will you use in every solar system or solar installation you are going to do in your projects? Or you have got a client, you need to design a solar panel. I told you how to design a solar panel. Now we need to see how can you design a charge controller. Remember we said a charge controller, it helps in controlling the battery charging. Okay, when the panel is charging, a charge controller helps to do the battery charging. Yes, it controls the battery charging. That is the use of a controller. Then we saw that these controllers, these charge regulators, they help in protecting the battery from damage. Okay, when the panel tries to bring too much voltages, the charge controller helps to protect the battery from being damaged. Then again we saw that these charge controllers, they improve the system voltages, okay, or they improve the system efficiency, the battery efficiency, or the solar system efficiency. These charge controllers, they have a lot to do. That's why we call them, they are the heart of the system. The whole solar system, the charge controller is the heart of this system. Without the charge controller, the system is under a fault condition. Everything will be under fault conditions, even though you wire them to properly. Just with the time, the battery is going to be damaged, the loads are going to be damaged, the panel is going to be damaged. Without this, which is the charge controller, which is connected between the solar panel and the battery plus the rod, it is in between. It is the one, it doesn't sleep, by the way. Remember, at night, a solar panel doesn't work because there is no sun. And at night, it is only the battery we need which works. Okay, now a charge controller blocks the battery voltages to go back to the panel. Okay, during the charge controller is helping the battery to charge at its maximum voltages. Okay, during at night, it is blocking the voltages when the battery is sending back the voltages to the loads, to the panel. The charge controller limits or refuses the voltage to flow back to the panel. You see how the charge controller is the heart of the system. It doesn't rest. It is full in time during day, at night. It controls also when the battery is fully discharged or overcharged. It disconnects the loads. Okay, disconnect the loads to save the lifetime or the lifespan of the battery. Meaning the charge controller, it doesn't. And in the morning, it must make sure the panel brings in voltages and it will be charging the battery. Meaning this charge controller, it doesn't rest. Whenever it is not connected in the system is in the uproar, is in danger, a serious one, danger. Okay, today we want to see how we can tell which charge controller can we use on our solar installation. After sizing your solar systems, what next? How can you size a charge controller? This is what we are going to see today. We're going to learn how to calculate any charge controller. Whatever any system you feel like you want to install, this formula is going to help you forever in any project you are handling of solar installations. Now, before we go much, let's talk about, I didn't tell you the specifications in the on the solar panels. Okay, solar panels have technical specifications. Let us call them the panel specifications. Okay, that is the technical seal behind the solar panel. They put a seal with technical information. Which technical information I mean? You will find some writings back the panel, a sticker. Okay, it will be like a sticker with this technical information. This technical information, we shall have maximum power. You'll find there maximum power written in the brackets PM. Let us say that this panel is rated at 250 watts. Okay, the maximum power. Then the short circuit current. You'll also see the short circuit current, which is ISC, which stands for short circuit current. This short circuit current, when you have connected the panel on the loads, this is the short circuit current. It will be, let us say it is 8.5 amps, because we're going to use this information when you're calculating your regulator. That's why we first studied or first did the lectures about the solar panels, because without solar panel you can't know which charge controller you're going to use. Okay, that's why we are moving slowly. Know how to calculate all the use of the panels. Then after getting the use of the panel, it will send you, when you're starting to get which charge controller are you going to use, it will give you a simple calculation when you have your solar system calculated. Now on a solar panel, again on the sticker, you will have a maximum power current. Let's say it is 7.9, which will indicate like IMP. Okay, then we shall have a maximum voltage. Okay, VMP, maximum voltage, meaning this panel will produce the maximum voltage when it is connected to the current, or to the, connected to the charge regulator or the loads. It will produce, when you measure your terminal, when connected the panel, it will give you 29.95 volts. Let's say that. Then you will see also an open circuit voltage when the panel is not connected in anywhere and is in exposure with the sun. It will give you, this is the VOC, the open circuit voltages. The maximum voltages, it is, when it is connected to the load, it is 29. When it is not connected to the load, the open circuit, it is open, the circuit is open, positive, negative, open. Okay, they will give you 39.25 volts. Okay, and this is when it is open. When it is connected, it will show 29 volts when it is charging the battery. But when it is open, meaning this system, when you see, when it is open circuit voltage 37, meaning if you can't put a 12 volts, that is too little. Okay, then two batteries, you make 24 volts, and if they are three in series, that is 36. Now 36, you can't put them on one open circuit voltage of the panel, which is 37. 36, those are three batteries, which are 12, that is 36, meaning you can't put it here. This system is for 24 volts, because when you put two batteries, which make 24, and this 37 volts will be able, because when you connect 24 with the 29, the maximum voltage when it's connected, giving you 29, meaning the 24 and 29, you see the difference. The difference is not much, meaning it will charge a system of 24 volts, these ratings. Okay, that's why I told you, the moment you first see, you calculate your panel, it will tell you the ratings. Okay, now we went on and see also the charge controller has specifications. Yes, it has a technical specifications. Which specification we shall see? I don't know if you're seeing, there is, we shall see a rated voltages. It will have rated voltage. This rated voltage, we mean on the charge controller. Behind it, you will see also a technical information. Always see a technical information before you buy. Read on the technical informations before you take a charge controller or a solar panel, so that you take the exact thing you have come for after doing the calculation. Okay, Now this rated voltage, we shall have the rated voltage. They mean the voltages this charge controller will work on. That is the 12 volts, the 24 volts, the 36 volts, and 48 volts. Okay, those are the voltage this charge controller will work on. Then you will see if this charge controller works on 12, you will see that it is rated only 12 volts. If it is going to work on 24, you will see that it is rated on only 24 volts. Rated voltage. If it is 36, it will be 36 volts. That's why I tell you, always read this technical information on the appliance you are buying. Okay. Now, another thing is you will see rated current. Okay. Now, this rated current, let us say, for me, I've put 60 amps. Okay, that's where we are going to see how do you come up to know that your current, you need a charge regulator of 60 amps. Okay, first of all, you have seen your system, you have designed your system is going to be 12 volts. Okay, now you don't know which amps. Now I have seen also the maximum PV input voltage, the maximum PV, the maximum photovoltaic input voltage, the input voltage which will come into a charge regulator. Me, I have used 100, okay? But the maximum PV input, the voltages from the charge, from the panels, okay? Me, I have put 100 volts. Now, a panel may be producing 21 volts. One panel. If they are two, that is 42 volts. Okay, until the maximum power, meaning this regulator can handle, if you add those voltages 21 until you get 100, that is the maximum PV input voltage they are meaning here. Okay, we go on the maximum PV input power. You see, we saw the voltage. Now we are seeing also there is also this charge controller also, it has its maximum limit of power. Power, I mean the watts. Okay, if it is in watts, it can handle, let us say, 780 watts. Okay, when it comes into the 780 watts, when it is watts not more than 1000, then that is a 12 volt battery. Okay, 12 volt battery always put on the system which is below 1000 watts. Then you can use a 24 volt battery on the system more than 1000 watts. 24 is good. When you go on 36 volt battery, that system, the power from the panel must be more than 2000. Okay, now more than 3000, you can use a 48 battery. You connect your battery to make 48 volts. That is when your panel is producing power wattage more than 3000. Okay, and that is the information you can see on the sticker behind the regulator or on the sticker behind a solar panel. Okay, now let us go back to what brought us today. Today we want to see how can I know the charge controller. Okay, how can I know the charge controller which I'm going to use? What formula am I going to use? The formula to use when you're getting the charge controllers. This is the formula you will already use. And as we said, charge controller current rating must be higher than the solar panel current. Listen this information. The charge controller rating, the current of a charge controller must be higher than the current of the solar panel. Okay, solar panel will be low with the current of charge controller must be higher, so that this charge controller will be in position to handle the solar currents. Okay, when the solar panel currents are higher than the charge controller, that is undersizing of the charge controller, you'll find that the charge controller will burn or get destroyed or damaged, okay, because of the high current from the panel. Now we said the charge controller must have high current than the solar panel. Always this, master this. Now, what formula can we use to calculate the charge controllers? Okay, what formulas can we use? Let us see the formula. Formula to use when you're calculating the charge controller. We are going to say, this is a simple calculation for the charge controller. You say charge controller current of the charge. We are looking for the current, because charge controller will talk about currents. If you're buying a charge controller, still you will talk about if you go on the shop, they will ask you for how many amps. Charge controller will deal about amps. We'll talk about amps. Okay, 60 amps, 15 amps, 5 amps, 10 amps. You see, 25 amps, 30 amps, 40 amps. It goes up to 100 amps. Charge controllers, you buy it according to the amperes, that is current from the panel, because we need to handle current from the panel so that we send it to the battery for charging. Now, what formula are we going to use? We are going to see that after knowing your solar panel short circuit current, yes, when you have connected your panel, the current which you will be having is 8.5. The formula is you multiply this short circuit current from the panel times the safety factor. You remember the safety factor I told you? The safety factor, this is a factor in case a customer has added on a bulb which you never calculated on your designing. That is the safety factor. We say the safety factor is, we said it is, let us call this current controller current is equals to solar panel short circuit. We are going to use the symbol for short circuit current. Solar panel short circuit current, which is ISC, times the safety factor. Okay, this is the formula. We will use this formula until whenever you want to calculate the charge controllers. You say you get your short circuit current times the safety factor, whereby the safety factor, I said safety factor will be, you remember I told you the other time I told you marginal safety. Let us call it today a safety factor, will be 1.25. This is the safety factor. Okay, when you're calculating a panel, you need to also apply the safety factor. When you're calculating regulators, you need to also apply the safety factor. Okay, whereby we said the controller current must be higher than the solar panel current. Okay, our controller must be, the current must be higher than the panel current. Okay, now let us see. If we said the solar panel short circuit current, this one short circuit current equals 80 times 5, we shall see that 80.5 amps times the safety factor, which is 1.25. This is, let us call it the current, the controller current. The current then C, which is, now what is the answer here? I would say 8.5 times 1.25. It will give us 10.6. Okay, it will give us 10.6. This is the controller current. This is in amps. This is our controller which you are going to get, which we'll use because, as we said, the controller current rating must be higher than the solar panel current. Remember, the solar panel we used the short circuit current. Okay, now we have got 10, and the short circuit current, it was 8. It means it is more than the panel current. This is the panel current. This is the controller you're going to use. But this is too little, or it is the one required to use on this system, on this solar panel. But we have this 6. If you round off, you make 11. There is no controller for 11 amps. Now, you add on small, like technically add on a small amps as you for safety still. Then we shall go which panel which is higher than this, which regulator which is higher than this, the 10 amps. Because if we have done the calculation, this is the simplest calculation you will always use. The solar panel short circuit current times the safety factor. Safety factor is 1.25. If you multiply this, I have used the the short circuit current from the solar panel, which is 8.5 times 1.25. It has given us 10.6 amps, which is the best. The calculation has given us this. But technically, you need to increase the nearest current amps, which is I'll use, therefore, the controller current, I'll use a 15 amps or a 20 amps. Okay? A 15 amp will work for you perfectly, or a 20 amps will work for you perfectly. And I can advise you to go with the 20 amps. Okay? Go with the 20 amps. Your system will work properly because this charge controller will be working on the currents coming from the solar panel, also working on the currents coming from the battery. So it is working on 2 currents. Okay? Normally 20 amps will work for you, but the calculation has given us 10 amps. Don't go for this 10 amps. Even though you go for it, it is good. It is good for you because the calculation have given you the proper measures. But you technically, you can use 20 amps. Okay? And your system will work smoothly. It will be able to handle this 8 amps, 8.5 amps. 20 amps will be able to use this for charging, and this 20 amps will be able to manage the current coming from the battery going to the loads to be used. Okay? And your solar panel will not heat, it will be calm, and the system will flow on very well. Only this formula you can manage to do a lot of things. You can also, let us say, we say you can do some examples. Change the short circuit current. Always see the panel behind and read the short circuit current is what we are going to use when you're calculating your regulator. Then the short circuit current times the safety factor. Safety factor is 1.25. Multiply them, you'll get the current, this current. Now, take this current and increase the nearest regulator above the answer you have got. The nearest regulator is 15 amps, 20 amps. Now you suggest that 20 amps can be the best for your system to work in a smooth running. Okay? Yeah. And remember this. The voltages, the controller voltages must match. Okay? The controller voltages, let me give you this hint. I know you have got some writing about this. Let me give you the hint about a charge controller. Charge controller has no match nodes. A charge controller voltages must match with the battery voltages. Okay, I'm saying when you see a rated voltages on the behind the charge controller, you'll see a sticker like this, technical sticker. Okay, this technical sticker, they will write for you rated voltages, rated voltage. This rated voltage is the one I'm meaning. It must match with the battery voltages. The battery you're going to use, if you're going to use a 12 volts battery, or if you're going to use a 24 volt battery, or if you're going to use a 36 volt battery, or if you're going to use a 48 volt battery, this regulator must match with the voltages you're going to use in the battery. Let us say if it is 12 volts, this regulator is rated at 12 volt. Okay, still your battery must match. You must use this regulator on the 12 volt battery. This is your battery, positive, negative. It must also be 12 volts. Okay, if you're going to use to connect in series your battery making 24, meaning if your regulator, if you read here on the rated voltages and there is no 24, please don't use it on 24 volt battery. It will get fault. Okay, it will not manage unless when they stroke here and they put 24 volts, 12 volts stroke 24 volts. You see, behind the regulator you'll find this sticker, a technical sticker having this information, meaning these voltages must match exactly with the voltage you're going to use. If the 24 is not there, please don't use this regulator. Use a regulator which is supporting 24 volts. Okay, now if you're going to connect your system in 36 volts, the battery, if your system this regulator is rated at the voltages at 12 stroke 24, please don't use on 36 voltages of the battery, unless go and look for a regulator if it is stroked 36 volts. There it can handle, meaning it can handle 12 volts, it can handle 24 volts, it can handle 36 volts. It does it automatic inside it electronically. This is what it means by matching. A regulator must match with the voltages in the battery. Okay, this I was giving you as a hint. Now you will find a rated voltages. This is the information. Then they will put also rated current. Rated current, the current which we have calculated, if you calculate your solar panel short circuit current times the safety factor, it gives you the current which we are going to use here. let's say we said we are going to use 20 amps. Always now, if you go to the market, look for a 20 amp regulator. Okay, look for a 20 amp regulator. Look for a 20 amp regulator. Don't say anything, or less than 25, still less than 25, 15 to work, because our calculation gave us 10 and we said let us use 20 amps. It will work for your system the way you want it. Okay, now another thing you will find, they will put a maximum PV input voltages. Maximum PV input voltages. Yeah, the maximum PV, they will put 100, let us say 100 volts, meaning your voltages, each panel, let us say each panel has 21 volts. 21 volts, meaning how many panels you add, the 21 volts you add to make 100 voltage. Meaning if you put 5, I think they are like four panels of 21 volts to reach the 100 voltage. Okay, now you'll find also maximum PV power. This is maximum PV power. Those are the power rating of the panels. You know, panels are rated in watts. Now the power rating of the panels, either 100 watts, 120 watts, 250 watts, 300 watts. This is what it means, the power rating of the, let us say 250 watts. Yes, and this is the information you will find on the regulator, on the charge controller or charge controller. Okay, this information will help you to know which controller is going to work well on your system after doing the calculation. The calculation is the current of the which we are looking, the current, this current of the charge controller is equals to the open circuit current of the panel times the safety factor. Safety factor is 1.25. You find this current on the panel, which is short circuit current, which is 8. Any panel has different current. Then get that short circuit current, which is 8 times 1.5. You'll get your solar charge controller current you will need to buy for your system. But after getting this answer, please try to get the nearest current amps of the one you have got, and they will be fine for your system. And this is how we calculate the charge controller of PWM or MPPT. The PWM or MPPT. This is the formula you use. Very simple formula. Yes. And this is how we shall finish our regulation, our charge controlling or regulation of the power from the panels. Now, the next thing we shall see is we are going to see how the batteries are connected from the solar panel to the regulator, then from the regulator to the batteries. Now the batteries are going to be charged. Okay, check in the next video. We shall see, we are going to handle the battery system, how the battery charges from, because it moves from the panel. It moves like this from the panel. We go to regulators, Then we go to the battery. Then we shall go to the loads. And we shall close our solar lessons. This is the movement, but we finished the panel. We have finished the regulators. Now we are going on the batteries. Okay? And soon we connect to the other lessons of electrical and electronics. Thank you for watching. See you in the next video.